Now let's solve this question, and this is taken from class 10 chapter 9 exercise 9.1, and third question is a contractor plans to install two slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree with the ground. Okay. Whereas for elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of slide in each case? So in this question, there are two slides given. One slide is given for junior students, okay, and other slide is given for elder children, sorry, okay. So for junior, for the students which are below the age of 5 years, she has planned for a slide which is at a height of 1.5 meters. See here, this is height of the slide. Suppose AB is the height of the slide, which is 1.5 meter, and children will go up from here and will come sliding from this way, okay. So this is the length of the slide. BC is the length of slide. This is length of slide. AB is the height of slide, and this is for the children which are below 5 years, right? In this case, we need to find out the length of this slide BC. So it's very easy. One length is given to us in right angle triangle, and this angle is also given to us, that this slope, or you can say this slide is inclined at an angle of 30 degree to the ground. This is inclination. Inclined means this angle is 30 degree given, right? So AB is given. We can find out BC by using T ratios, trigonometric ratios. So in the second case, what is given, that for elder children, she prefers to have a slide of height 3 meter. So here this height is 3 meter, right? Suppose PQ is this. This is 3 meter given in this case, and this is the slide, right? It is very straight otherwise. So this is slide. Now suppose this is QR is the length of the slide, and PQ is given the height of the slide, and now this slide is making an angle of 60 degree with the ground. So this angle is 60 degree. In this case also we need to find out QR, right? So one length is given PQ. We can find out QR easily with the help of T ratios. Now first of all, we'll explain the figure here, then we'll start solving these two questions, these two parts. So for children below 5 years, BC is a slide, AB is 1.5 meter height of the slide, angle C is 30 degree. Now in right angle triangle ABC, so BC we have to find out, so BC will write in the numerator over what is given, AB height is given, so AB in the denominator. So let's see which T ratio is made here. So BC over AB, this is H over P with respect to angle 30. H over P. So P over H is sine theta. So H over P is cosecant theta, reciprocal of sine. So cosecant 30 will come here. So BC over AB. AB is given 1.5. Now cosecant 30. You know sine 30 is 1 by 2. So reciprocal of sine 30 is 2 over 1. That is 2 only. So BC is equal to cross multiply. So 1.5 into 2 is 3 meter. So length of the slide for the children below the age of 5 years is 3 meter. So now let's find out the length of the slide in other case. So for elder children, QR is a slide here, PQ is the height of the slide, that is 3 meter, and R angle is 60 degree given. So in right angle triangle PQR, we need to find out RQ or QR. So I'll write QR here over PQ is given, so PQ in the denominator is equal to, again it is H over P, that is cosecant 60 degree. So it is cosecant 60 degree. Now QR is to be found out. PQ is 3 meter, and now cosecant 60. So sine 60 is root 3 by 2. So cosecant 60 is 2 by root 3, right? So QR will be, now cross multiply, 3 will go here in the numerator, so 6 over root 3, and you can rationalize here, so root 3 over root 3. So it becomes 6 root 3 over root 3 into root 3 is 3. So 3 ones are 3 twos are. So 2 root 3 meter is the height is the length of the slide in this case. So in first case it is 3 meter, in second case it is 2 root 3 meter. So this way we will do this question.